Yes, sir. Very good evening to you all. Shri Kumarswami Mahavidyalaya, Ausa, District Latur. It's organized a World Record Series 2. Today there is 343rd day of the series. And the keynote speaker for today's session is with us Honorable Dr. Janhavi Karekar ma'am. So first of all, I heartily welcome to you, madam.
Thank you, sir.
I welcome the chief organizer, the ideal principal of Shri Kumarswami Mahavidyalaya Ausa, Honorable Dr. M. Bedkar sir. Also welcome faculties of my college and all those dear participants. Today's topic for presentation is application of ion exchange resins in environmental remediations. Now this topic is going to present Dr. Janhavi ma'am. Presently she is serving as an assistant professor at KLS Gogte Institute of Technology, Belagavi, Karnataka. So with this brief introduction, now I request to you, madam, please start your presentation on this topic, application of ion exchange resins in environmental remediation. You are most welcome.
Thank you, sir. Thank you for the introduction. So I'll start. I'll share the screen, sir.
Yes, ma'am. Yes, please.
Sir, an error has occurred when screen sharing, it is saying.
Principal sir will help, madam. Just please. Sir, please.
So slide is visible?
Yes, madam. It's visible. Yes, ma'am. Yes.
Thank you, sir. Thank you for giving me opportunity to present my topic in this webinar series. So my topic of presentation already mentioned. So it is like applications of ion exchange resin in environmental remediation. I am Dr. Janhavi Karekar, Assistant Professor in the Department of Chemistry, KLS Gogte Institute of Technology, Belagavi, Karnataka. So my slides start with what is environmental remediation. As the topic in itself indicates, it is environmental remediation. So we must know what is exactly the meaning of environmental remediation is. So environmental remediation is nothing but it is the removal of pollutants or the contaminants from the water. It may be a groundwater or surface water, and also from the soil. And water remediation I am going to focus, and it is a process where the polluted water can be treated for the removal of pollutants or converting these pollutants into harmless products. And why we must carry out this environmental remediation? So that we can protect the human health as well as restore the environment. So what are the causes of water contamination? So there are several causes of water contamination. One of the causes like domestic sewage that is being let into the water, that is river waters or the sea water. Then mining resources, mining activities that are being carried out. So that also going to be part of water contamination. Then natural source like the volcanic activities or the plutonic activities that take place, and due to nature, in the nature, some of the contaminants already get included into the water. Increase in the urbanization process, then industrial sources, different industry, when they are using the water, the effluent, untreated effluent could be the source of water contamination. The agriculture source, like we use the fertilizers, pesticides, the insecticides, etc. So that may percolate into the groundwater or the surface water. And these are the reasons for the water contaminations. And here are some of the live images where you can see here the yellow color water which is coming into the stream, and this is said to be the chromium contaminated water led from the plating industry. This is leather tanning industry which uses the chromium. Then different industry are going to add to the water contamination. The mining industries, fertilizers industries, steel industries, and so on. And the type of contaminants that get added into water, these include heavy metal ions, toxic anions, emerging organic contaminants. Like the emerging organic contaminants are nothing but the pharmaceutical compounds in trace amount, but still they are hazardous. Pesticides, the organic waste in the form of phenols or the cosmetic reagents that may get added into the water. The organic dyes which come through the textile industries, and radionuclides also, the radioactive waste also may contaminate the water. And here is the chart which includes so different heavy metal ions. If their permissible limit exceeds beyond these milligrams per liter, which is shown in the chart, then it is going to affect the human health. So arsenic, cadmium, chromium, mercury, these are very poisonous elements when they are get added into the water through the human activities. Then definitely they cause the severe health effects like the cancer, they may affect the functioning of the kidneys, lungs, livers, etc. And the anions in the same manner could be added into the environment through the human activities, and they are also lead to the health effects. So here some of the health effects are mentioned in the chart. So how to overcome these contaminants from the water? So what is the remediation measures we must take to remove these water pollutants? So the methods that are included are chemical precipitation, ion exchange, adsorption, filtration by using different membrane techniques, then flocculation, coagulation, flotation, the regular techniques, and then electrochemical techniques. Among so many methods of water remediation, so adsorption is said to be the effective method in cleaning pollutants from the water and wastewater streams. The adsorbents that are used for the adsorption process for the removal of contaminants include activated carbon, hydrogels, nanoparticles, nanocomposites, the materials based on silica, biopolymers like chitosan, chitin, then bio-based adsorbents, microparticles made of polymers, and ion exchange resins. Among these, the most popular and effective adsorbent that is being utilized by the industrial processes are ion exchange resins. Why ion exchange resins are used? What is the reason for using ion exchange resins? As I mentioned, different adsorbents could be used for removal of the contamination of water, but ion exchange resins, they find many advantages over the other adsorbents. One of the advantages, their high selectivity towards specific ions. Then they are highly stable, mechanically stable as well as chemically stable. So the temperature variation will not lead to the mechanical changes in the resin. Also chemically it won't get affected. Then the cost of regeneration is less. Regeneration is nothing but once the resin is used, it can be reused by carrying out the process called as regeneration. So when regeneration is done, low cost reagents could be used, and hence the regeneration process of ion exchange resins involves the cost very less, and the sludge formation is very limited, and with the help of ion exchange resin we can even recover the metals like chrome plating industry. If the chromium is getting letted out into the water stream, so that chromium can be recovered, or else the precious elements like platinum, palladium, gold, etc. can be recovered by using the ion exchange resins because of their high selectivity towards specific ions. Energy required is less, and if the resin beds are well maintained, those can last for many years together. So these are some of the advantages of these ion exchange resins. But along with the advantages, few disadvantages or limitations I can say are also present when we use this ion exchange resin. One of the limitation is the operation cost may get higher if we are going to use ion exchange resins for the longer term, and regeneration of some of the ion exchange resin is not possible. In that case, the cost of the process may go high. So these are some of the limitations. But if we see at the advantages of these ion exchange resins are more. Then coming to what are ion exchange resins? We are talking about the ion exchange resin for the environmental remediation. So then what exactly ion exchange resins are? What they are made up of? These ion exchange resins are nothing but insoluble, cross-linked, long-chain, high molecular weight organic polymers, wherein they will be having the functional group attached to these cross-linked polymeric chains, and these ion exchange resin act as a medium for the exchange of ions. Ion exchange resins are nothing but these are insoluble cross-linked polymeric materials which are having functional groups, and because of the functional group attached, these resins could act as a medium for the exchange of ions. And the ion exchange process is called as reversible exchange process because there is exchange of ions between a liquid and the solid medium. And this ion exchange process is most utilized technique in the water and wastewater treatment. So which exactly the polymers are used? So ion exchange resin, basically they are made up of polystyrene and polyacrylate. Other polymeric substances also can be utilized, but basically polystyrene and polyacrylate resins are synthetically available, and their bead size, they are in spherical form, and their bead size may vary in the range of 0.3 to 1.3 millimeters. So in this figure, we can see the polymeric bead, nothing but this is ion exchange resin. So this is a monomer converted into polymeric form, this red color line which you can observe here. So it is a polymeric chain with a cross-linking agent so that the polymeric chains can bind towards each other through the cross-linking, and the functional groups are attached over the polymeric chain. So this blue color indicates the resin fixed ion, and the yellow color one indicates the counter ion, so which is just oppositely charged that of this resin fixed ion. So here in this figure also you can see there is a polymer matrix which is connected to the resin fixed ion, and there is a counter ion. When this resin come in contact with the solution containing other ions, the exchange of ions happen. The counter ion get exchanged with the ion present in the analyte solution, and hence this process is called as ion exchange process. So these are the steps that are involved when we are going to synthesize any ion exchange resin. The first step is conversion of monomer into polymer through the polymerization process. Use a particular monomer of which you want polymer to be made using a specific conditions as well as the initiator for the initiation of the polymerization reaction. So a long chain polymer is formed, a linear polymer is formed, but if you want to bring them together polymeric chains, so you must use the cross-linking agent. So most of the time the cross-linking agent used is divinyl benzene. So here you can see the polymeric chains which are just linear, they get cross-linked between each other through this cross-linking agent. And at the end of the process, the functional groups are also added to the resin network so that they can have this resin fixed ion and the counter ion. This counter ion will be able to exchange with the solution ion. So this is how, these are the steps. First is polymerization reaction, then cross-linking reaction, and then adding the functional groups into the cross-link polymer network. Based on which functional group you are introducing into the polymer matrix, the ion exchange resin basically have been classified into two types: cation exchange resins and anion exchange resins. The cation exchange resin further subdivided as strong acid and weak acid, and anion exchange resins have been subdivided as strong base and weak base anion exchange resins. Why these resins, cation exchange resins, are called as cation exchange resins? The reason is they are able to exchange the cations present in the external solution, because in this case the resin fixed ion is negative, whereas the counter ion is positively charged. And in strong acid cation exchange resin, the functional group that is being introduced, it is sulfonic acid group. And in weak acid cation exchange resin, the functional group introduced is carboxylate acid. So carboxylate ion will be the resin fixed ion. The H plus ions are the exchangeable ions. Similarly, in anion exchange resins, the counter ion will be in the form of anion, so which can get exchanged with the anion of the external solution. So if we introduce this quaternary ammonium group, it becomes strong base anion exchanger. If we introduce primary or secondary or tertiary amine groups on the polymer matrix, then that resin will behave as weak base anion exchange resin. There are special type of resins as well, which are called as chelating resins. And the reason to call them as the chelating resins is that when they come in contact with the metal ions in the external solution, they are going to form a chelate, a complex with those metal ions, and hence they are called as chelating resins. They are very, very specific to particular ions, and they they can selectively remove those ions from the solution. So there are a few more types of ions based on the pore size. Gel type of resin, which is a transparent resin, and it is shiny. It is also called as microporous resin, whose pore size will be very small when compared to that of macroporous resin. So macroporous resin pore size will vary between 10 to 1000 nanometer, and isoporous resins are the resins wherein the pore size is equal. It is same throughout the all the resins. And one more special type of resins which is found in the market, that is called as magnetic resin. And why it is called as magnetic resin? Because it can remove the magnetic impurities from the water. So therefore it is called as magnetic resin. The ion exchange resin find application in vast areas. One of the most profound area that is being used is water softening, for the water softening purpose. Then wastewater treatment purpose, ion exchange resins are used. Even in the beverage industries, juice industries, ion exchange resins are used to obtain a particular taste, color to the beverage or the juice. Then in catalysis, so several chemical reactions are carried out in presence of ion exchange resins, where these are used as a catalyst. In the metal separation process, in sugar industry, for the removal of coloring, dark color of the sugar, decolorization of the sugar is done in presence of ion exchange resin. And also these ion exchange resins find application even in the pharmaceutical industry. So how softening of water takes place? By using the ion exchange resin. Here is the process shown. So the hard water is passed over the ion exchange resin column. The ion exchange resin column, if you want, convert hard water into soft water. The ion exchange resin column could be only single column having the cation exchanger. And the cation exchanger, here the counter ion is present in the form of sodium ions. When hardness of water is due to presence of dissolved salts of calcium and magnesium. When this hard water comes in contact with the ion exchange resin, which is in the sodium form, so the exchange of ions takes place. So calcium and magnesium ions, they go on the resin, and sodium ion come into the solution. So thus the water will be free from calcium and magnesium ions and it becomes soft. If we don't want even the negative ions to be present in the solution or the positive ions into the solution, the water has to be totally demineralized, or we want a distilled water which can be used for many of the chemical processes. And in that case, so two ion exchange resin beds we must use. The first ion exchange resin bed should be cation exchange resin bed, and then the anion exchange resin bed. The raw water is passed over the cation exchange resin bed where the cations gets exchanged with the H plus form of the resin. So H plus ions will come into the solution along with the negative ions which have been left out without absorption on the resin. Then this water is with the help of pellistatic pump is sent into the through the anion exchange resin bed where the resin is in the OH minus form. So the chloride ions or the sulfate ions, they get exchanged with the OH minus ions. So previous H plus ions and then these OH minus ions which come into the solution, they get added up to form water. So thus water coming out of this technique will be totally demineralized. So this process can be a continuous process for certain period, but after some time when these exchangeable sites are not available for the exchange, then these need to be regenerated. And as I said in the beginning, the ion exchange resins, they have got the low regeneration cost because the low cost regenerants are used. For example, HCl could be used or NaOH could be used for regeneration of resin. So again, the resin can be obtained in the same form by treating them with this HCl or NaOH. And this is the image wherein you can see the wastewater can be treated at the industry by using the ion exchange resin. So big columns are used for removal of the wastewater, the contaminants present in the wastewater. So here in this further slide, I will be dealing with the exactly methodology that is being formed that can be utilized for the removal of toxic ions by using the ion exchange resins. So what is the technology that is being used or the methodology that is being used? So there are two ways of carrying out the removal of contaminants by using the ion exchange resin. One of the ways is batch adsorption technique and the other one is column technique. Here I'm going to just discuss about the batch adsorption technique. So for the small amount of resin, how we can carry out the testing of the contaminant present in the water for that removal. So in batch experiment, what has been done? A known amount of resin is taken with the liquid solution of known concentration in the stoppered flask, and then these flasks are agitated or they are kept for the shaking in the shaker, which can be controlled with which has got the thermostat controller. And during the process, we need to keep it for some time for till the equilibrium is attained. And the concentration after the adsorption has to be analyzed by using specific analytical techniques. So suppose if you are using the cation exchangers, then if you want to remove the Y plus ions present in the solution, then the reaction is going to happen like this. These Y plus ions, they come on the resin and H plus ions, they go into the solution. But depending upon the capacity of the resin, either all Y plus ions may go on the resin or may not. Some may be left out into the solution. And those have to be analyzed by using the analytical techniques. In the same manner, the negative ions will get exchanged with the OH minus ions present on the resin. And the analysis of these negative ions has to be done by using specific analytical techniques. So here in this schematic diagram, how exactly the process can be carried out is shown. The resin of known quantity is taken, the solution of known volume of known concentration is added, the flasks are stopped, and using a shaker, the flask cap for shaking till the equilibrium is attained. Then the solution is separated from the adsorbent, where here the ion exchange resins are used as adsorbents. And after separation, after filtration, the filtrate is analyzed by using the analytic techniques like spectrophotometric techniques can be utilized. For chromium analysis, we can use the diphenyl DPC method, and for fluorine removal or for fluorine testing, we can make use of the fluorine ion electrode, so which can give the correct results of the amount of ions left out after the adsorption. So different analytical techniques can be utilized to check how much amount of ions is left out after the equilibrium is attained. Then we must vary different parameters for getting the optimum condition of the process. So how much contact time we must keep, how much adsorbent dose, so how much quantity of resin should be taken, what pH has to be maintained, what should be the concentration, moderate concentration that has to be used, and temperature, how much we must maintain. So to get the optimum condition, we must vary these parameters. So contact time, so you should keep on increasing the time of contact and just observe after particular time how much is the percentage removal of the ions. Then adsorbent dose, you have to vary the resin quantity. You have to change the pH, because most of the time the ion may behave differently at different pH condition, or the adsorbent property may vary at different pH conditions. So pH is one of the important parameter to be verified during the adsorption study. And the initial concentration, so how much concentration can be used for the removal of those ions effectively, that also need to be checked. So from lower concentration to higher concentration, we can vary. The temperature also can be varied. Room temperature, less than room temperature, above room temperature, we can vary and check at what optimum temperature the removal efficiency is more. So these studies need to be carried out so that we can say at the end, so these are the conditions we must maintain so that the maximum removal is possible by using these particular resins. Then calculation includes, so we must calculate the distribution coefficient, which is the ratio of the amount of ion on the resin and the amount of ions left out in the solution after the equilibrium is attained. Then adsorption capacity, what is the amount of adsorption that is going to happen per unit mass of the adsorbent, need to be calculated using this formula. And the removal efficiency, so most of the time in the papers it is mentioned the removal efficiency of this adsorbent is this much. So for removal efficiency, we must utilize this formula. So Ca by C naught. So the amount of ions on the resin, their concentration upon the initial concentrations, that ratio if we take, so that gives us the removal efficiency. So if we multiply into 100, that gives us percentage removal efficiency. Then also the data has to be represented in the form of graphs, which are called as adsorption isotherms. And these adsorption isotherms are nothing but graphical representation where we can show the variation in the amount of adsorbate on the adsorbent with the change in the concentration of the adsorbate by keeping the temperature constant. So there are different isotherms that could be used for the generated data. So most of the time, Langmuir adsorption isotherm and Freundlich adsorption isotherms are utilized. And Langmuir adsorption isotherm is applicable for monolayer adsorption on the homogeneous surface, which states that there is no interaction between the adsorbate on the different site. Whereas Freundlich adsorption isotherm is applicable for multi-layer adsorption on the heterogeneous surface when the interaction occurs between the adsorption species. So when we have to say this, like the adsorption process has followed Langmuir adsorption isotherm, so the adsorption is unilayer or the adsorption is multi-layer, then for that the data has to be collected, and that has to be plotted by using the Langmuir adsorption isotherm. So this equation we must utilize, and using the graph, that is C versus C by QE, we must plot a graph. So if we get a straight line where almost all points are passing through the line, then that indicates the adsorption process follows Langmuir adsorption. And in the same manner, the Freundlich adsorption isotherm, so we must plot log QV versus log CE, because we are using here linear form of Freundlich adsorption isotherm. So log CE versus log QV, when we plot, we are going to get the two terms, the important terms. One is Kf, that is Freundlich constant, which indicates the adsorption capacity, and Nf, which is the adsorption intensity. Now suppose if I got a data, and if I apply that data for both these adsorption isotherms, and only the data is going to properly is going to fit into a particular adsorption isotherm. Let's see, the points are not at all on the line, and the regression coefficient is not 1, it is very, very less. And the Langmuir adsorption isotherm, the regression coefficient is almost 1, and all points are covering on the line. That means the adsorption process follows Langmuir adsorption. And what does it indicate? The process is unilayer, it is monolayer. The adsorbent has coated with a single layer of adsorbate. So that is what the conclusion we can make. And if it doesn't follow Langmuir, and if it follows Freundlich, then the adsorption has taken place multi-layer on the heterogeneous system. So that's how we can correlate the isotherms with our adsorption data. Similarly, the adsorption kinetics also very important process, or it is a step which can give the valuable information on stating the adsorption mechanism and potential rate limiting step for the process. So this is also very important step, so that we can optimize the process parameters and best condition for the large scale removal application. So which models are used? Pseudo first order kinetic model, pseudo second order kinetic model, Elovich, intraparticle diffusion models, and so many other models can be applied to obtain kinetic data. So in this slide, I have shown two models. One is pseudo first order kinetic model and pseudo second order kinetic model. So pseudo first order kinetic model indicates if your data fits well into pseudo first order kinetic model, then the rate limiting step is chemisorption, whereas if it is it is surface diffusion. Whereas if pseudo second order model fits well for your data, then the rate limiting step is chemisorption. So thus you can conclude like what kind of adsorption is happening and what is the rate limiting step that is taking place in the adsorption process. And at the end, so when we are supposed to publish a data into a reputed journals, then just our data is not enough in the form of graphs and the models. We must do the characterization of the adsorbent material. Why this characterization is important? Because it enables us in identification, location, quantification of the chemical constituents in the form of which elements are present, which functional groups are present, what is the kind of molecule that it is, what is the structure, topography of that molecule or the adsorbent, what is the morphology, what is the what are its magnetic property, what is its size, and so on. So definitely the characterization properties need to be studied by the any of the researchers when the paper or the work has to be published. The different analytical techniques or the characterization techniques that are used. Chemical characterization techniques involve UV visible spectroscopy, FTIR spectroscopy, then Raman spectroscopy, X-ray diffraction, then X-ray energy dispersive spectroscopy, zeta potential, etc. The thermal analysis can be done by using thermogravimetric analysis, differential thermal analysis, differential scanning, calorimetry techniques, and so on. And physical characterization techniques include X-ray diffraction techniques, the scanning electron microscopy, transmission electron microscopy, and so on. So most of the time, one chemical characterization technique and one physical characterization technique is essential to publish a work in the reputed journal. More are the characterization techniques that are involved in the paper, then the paper gets easily accepted, along with the proper justification, proper explanation if it is given. So with this, I'll conclude. So in the conclusion slide, so whatever I have till now presented, in brief, I will list it out. Ion exchange process is most widely used industrial process for the removal of toxic ions from the water and wastewater streams. So it finds many applications over the other methods. And for understanding maximum removal efficiency, optimization of the process condition is very essential. And to understand the relation between the concentration of adsorbate in the solution and on the adsorbent, the adsorption isotherms must be utilized. And to know the possible adsorption mechanism and their potential rate limiting step, adsorption kinetic models need to be used. And we must do the characterization of the adsorbent so that it can provide the basic information about the adsorbent. So with this, I'll conclude my presentation. Thank you one and all for your patient listening.
Thank you so much, madam, for the wonderful presentation. Now it's a time for discussion. Participants are requested to please discuss with resource person. Dear participants. Yes, Dr. Swami Shukla, sir.
Hello, good evening, Dr. Bedkar sir, Principal sir, Prashant sir, and good evening, ma'am. Wonderful presentation you made, and one of the very important topic, as per my knowledge, yes, definitely you have gone with the depth, and you talked about so many things, but I'm not a student of chemistry, so I could not understand. But I know the base exchange process and sodium permutate, what we call it as. And the hard water is one of them, nowadays we are using bore water and we are using hard water. The mineral contents are very high. And in this instance, you'll find this sodium permutate or this base exchange process is very important. So I think we can achieve zero hardness also. That becomes, you'll find the hardness is soft water and that is more corrosive in nature also. Yes. So I think we are using this in industries, various industries where we want this kind of water. And yes, definitely big plants are there. I have learned about this somehow, because of one of the very important topic of water filtration. And here, you have the calcium and magnesium, the ion, that what we call it as a temporary hardness, is exchanged with any, sodium, aluminum, water, silica, that kind of, the permutate or base exchange I have learned. And that replaces the things. So that is how we have learned about the very important that exchange process. So if we are using a base exchange process, what are the disadvantages? That is one of the questions, right? And can we apply this, not only for wastewater management or water purification to remove contamination, but can we use it to purify our rivers also? Can we put some baits or something like that in the river? That is my question. Thank you, ma'am.
Thank you, sir. So, as I mentioned in one of the slides, the limitations of the ion exchange processes are like these are costly, and for long-term uses, if you want to use the ion exchange resins, then definitely the cost of the process will go high. And if you want to utilize this ion exchange resin for the removal of contaminants present in the river water directly, then the cost of the process will go high because the resins are costly. So that is one of the disadvantage. So for means like small scale, we can use these ion exchange resin, but large investment is required if want to go for a removal of contaminants present in the water, river water. So, but it can be utilized.
Yeah, thank you, madam. So we can use it for smaller unit like hospitals, and we can use it for industry purpose where they want that kind of level of water. So we can use it. Means it is cost effective. Thank you. Thank you very much. Yeah.
Thank you.
Anybody else? So thank you so much, Dr. Swani Shukla sir, for the nice question. Madam, you have answered it very well. Now I request the chief organizer of the series, Dr. M. Betkar sir, to conclude the session. Please welcome, sir.
Thank you, sir. Thank you, Betkar sir. Thank you, Prashant sir, for giving me opportunity in this webinar and making me as a part of this world record webinar series. Thank you so much, sir.
Just wait for formal vote of thanks. Ma'am, please. So thank you, sir. Now I move towards the vote of thanks. Shri Kumarswami Mahavidyalaya Ausa, District Latur. We know organized the World Record Series 2. Today we have completed 343rd day of the series. And the topic was new for us because we people are from different faculties, subjects. And the topic was new, but the topic have presented so nicely, clearly in a simple language by today's resource person, Dr. Janhavi Karekar ma'am, where she explained all those details regarding the topic, what is environmental remediations, then the different methods of contaminated water remediations, why ion exchange resins, then what are ion exchange resins, then the synthesis of ion exchange, then different type of ion exchange resins, and all those points regarding the topic by giving different examples. It is very clearly you mentioned, madam, all those things. So we understood a lot from this new topic. So I'm very, very thankful to you on behalf of the organizing committee members. Also thanks the chief organizer, Dr. M. Betkar sir. Special thanks to Dr. Swani Shukla sir. Also thanks to Dr. Sanjay Kant sir, Dr. Kokne sir. And I should not forget to thanks all those dear participants who joins the series regularly, and that's why we are moving ahead. So once again, thanks a lot to you all for being with us every day on time. Now I request you all please fill the feedback link which is given in the chat box. With the kind permission of the chief organizer, I declare the session is over here. Thank you so much. Thank you, Janhavi madam.
Thank you, sir.
For
Thank
your-
you so much.
Thank you, ma'am. Thank you, Betka sir. Thank you, Prashant sir. Thank you.
Thank you.
Thank you, madam. Thank you very much.
Thank you, ma'am. Thank you.
Thank you, sir. Thank you, ma'am.
Thank you, sir.
Hello. So you said something?